There is a place on this planet where it has not properly rained in living memory. Not in years. In some spots, the records suggest, not in centuries. The ground is cracked and bare. There are weather stations sitting in this desert that have, across decades of measurement, recorded essentially no rainfall at all. The soil is so dry, so utterly stripped of moisture, that scientists bring their Mars rovers here to test them, because this corner of Earth is the closest thing we have to the dead, parched surface of another planet. Stand in the worst of it, and you are standing somewhere drier than the red dust of Mars. Nothing should be able to live here. By every rule you think you know about life, this should be a sterile, empty wasteland. And yet it is not empty. That is the impossible thing. Move through this desert and you find life clinging on. Plants, insects, animals, whole small ecosystems surviving in a place where the rain never comes. And that confronts you with a question that sounds almost like a riddle. Every living thing on Earth needs water. Without water, there is no life. Anywhere, full stop. So how is anything alive in a place with no rain? Where is the water coming from? It's not falling from the sky. It's not bubbling up from a river. So where? The answer is one of the most beautiful and cunning stories in all of nature. Because the life in these deserts has pulled off a kind of theft. It has learned to steal water out of thin air. Not from the ground, not from the rain, but directly from the wind itself. Every creature, every plant down here is, in its own way, a thief. And what they're stealing is moisture out of the very air they breathe. And the tricks they've evolved to do it are so strange, so clever, so close to impossible, that human engineers are now copying them to try and pull drinking water out of the sky. Over the next 40 minutes, we are going to uncover exactly how they do it. We're going to follow the water from where it's borne out over the cold ocean to the moment a single drop is captured by a beetle standing on its head, to the trees that comb it out of the fog, all the way up through an entire chain of living things that survive on stolen air. And by the end, you'll understand how a place drier than Mars can be quietly, secretly, full of life. If you want to follow that drop of water all the way through, make sure you're subscribed before we begin, because this is a story about survival pushed to the absolute edge of what's possible, and it's happening in some of the emptiest places on Earth. So let's begin where the mystery is sharpest. Let's go to the driest deserts in the world. There are two great stages for this story, on opposite sides of the planet, and they are mirror images of each other. One is the Atacama Desert, running down the western edge of South America, pressed between the Pacific Ocean and the towering wall of the Andes Mountains. The other is the Namib Desert, on the southwestern coast of Africa, a ribbon of ancient sand caught between the Atlantic and the dry African interior. They are thousands of kilometers apart, on different continents, in different hemispheres, and yet they share the same brutal contradiction and the same secret solution. In both places, you have genuine, extreme, almost absolute desert. We are not talking about a dry region that gets a bit of rain now and then. We are talking about some of the most arid land that exists anywhere on the surface of this world. In parts of the Atacama, the average rainfall is so close to zero that it's hard to even measure. There are valleys that may go years without a single drop, places where the dryness has been baked in for an unimaginably long time. The Namib, too, is staggeringly old and staggeringly dry, a desert that has existed for millions of years, one of the most ancient deserts on the planet. These are not gentle places. The sun is relentless. The ground is hostile. Liquid water, the thing every cell of every living thing depends on, is almost entirely absent. And here's what makes it even stranger. Both of these deserts sit right next to an ocean. Right next to it. You can stand in the sand of the Namib and look out at the cold gray Atlantic crashing on the shore. You can be in the coastal Atacama with the vast Pacific stretching to the horizon. There is an entire ocean of water, right there, a few steps away. And it does almost nothing for the land. The desert stays bone dry, parched, lifeless looking, with one of the largest bodies of water on Earth lapping at its edge. A desert dying of thirst on the shore of an ocean. If anything, that makes the riddle worse, not better. The water is right there, and yet the rain still won't come. So to solve this, we have to answer two things. First, why is it so dry here? when the ocean is right next door? And second, if the rain won't fall, then what is the hidden source of water that keeps all this life alive? And the astonishing thing is that both questions have the same answer. The exact same feature of this coast is the reason there's no rain, and the reason there's any life at all. To find it, we have to go offshore, out over that cold ocean, and watch something extraordinary being born over the water. Out beyond the surf, the ocean along these coasts is doing something unusual. It is cold, strangely, bitterly cold, far colder than you'd expect for water sitting under a strong subtropical sun. And that cold is the key to everything, because along both of these coastlines, deep ocean currents and rising water from far below bring cold water up to the surface and sweep it along the shore. The sea here isn't warm and tropical, it's chilled, and that single fact rewrites the weather of the entire coastline. Here's why that matters. Normally, for rain to form, you want warm ocean water. Warm water evaporates easily, feeding warm, moist air that rises high into the sky, cools as it climbs, and forms towering clouds that eventually burst into rain. That's the engine of rainfall over much of the world. But over cold water, that engine stalls. The cold sea chills the air sitting just above it, and cool air can't rise and tower the way warm air does. Instead, it stays low, hugging the surface, heavy and stable. So the great rainmaking process never gets started. The clouds that would normally build up and break never form. The result is a coast where the air is actually full of moisture, but it just sits there, low and trapped, unable to turn into rain. That's the first half of the answer. The cold current is exactly why these deserts are so dry. It strangles the rain before it can ever begin. But that same cold current is also about to give life its lifeline. Because while that chilled, moisture-laden air can't form rain clouds high in the sky, it can do something else. As the air sits over the cold water, it cools to the point where the moisture in it begins to condense, not into high rain clouds, but into a thick, low blanket of fog right down at the surface of the sea. A dense rolling bank of fog, borne over the cold ocean, heavy with tiny droplets of water. And then the wind picks it up and pushes it inland, rolling it off the sea and onto the thirsty land like a slow gray tide. This is the secret. This is the hidden river of these deserts. Not a river of liquid water on the ground, but a river of fog in the air. In the Namib, this fog has a name among the people who live there, and it comes creeping in from the Atlantic, often at night and in the early morning, blanketing the dunes in cool gray mist. In the coastal hills of the Atacama and the deserts of Peru just to the north, the same thing happens, a thick fog rolling in off the Pacific. The rain almost never comes, but the fog comes again and again, a ghostly tide of moisture sweeping in from the sea. And now you can feel the shape of the problem that life had to solve. There is water here. It's right there in the air, drifting past in the fog, billions upon billions of microscopic droplets. But it is almost impossibly hard to get. Fog droplets are tiny, far smaller than raindrops, so light they barely fall at all. They just drift on the wind. You can't drink fog. You can't soak it up from the ground because it never pools into anything. It hangs in the air and slips past you, and if you can't grab it, it's gone, blown on inland to evaporate as the day warms up. The water is there, but it's locked in a form that almost nothing can use. Almost nothing. Because life, given millions of years and the brutal pressure to survive, found a way. Several ways, actually. Ingenious, bizarre, beautiful ways of reaching into that passing fog and stealing the water out of it before it disappears. The creatures and plants of these deserts became fog thieves, each with its own method, its own tool, its own trick for catching droplets out of the moving air. And the first of these thieves, the most famous of them all, performs a feat so strange that when you first see it, you can hardly believe it's real. If you're already hooked on this, that an entire living world is surviving by robbing the wind, drop the word fog in the comments so I know you're with me. And let me introduce you to a small creature that solved this problem in the most theatrical way imaginable. It climbs to the top of a sand dune in the path of the incoming mist, and it stands on its head. The star of this part of the story is a beetle. A small, dark beetle that lives in the dunes of the Namib Desert, one of the driest places on the whole continent of Africa. And the way it drinks is one of the most remarkable behaviors in the entire animal kingdom. On the mornings when the fog rolls in off the Atlantic, this little beetle does something deliberate and precise. It climbs. It hauls itself up to the crest of a sand dune, up to the highest point it can reach, right into the path of the incoming mist. And then, when the fog is moving over it, the beetle plants its front legs, lowers its head, and lifts its back end high into the air. It tilts its whole body, head down, rear up, facing into the wind. It stands, essentially, on its head. And then it just waits. It holds that strange pose as the fog drifts past, and the tiny droplets of water suspended in the air begin to strike its raised back. Droplet by droplet, the moisture collects on the beetle's body. And the beetle's back is not just any surface. Its shell has a microscopic texture, a precise pattern at a scale far too small for us to see, that is fantastically good at grabbing water out of fog. Some parts of its surface attract water, pulling the droplets in and helping them stick and gather. Other parts repel water, encouraging the collected droplets to beat up and roll. So as the beetle stands there, head down, the tiny droplets land, merge into bigger droplets, and grow. And once a droplet gets big enough and heavy enough, gravity takes over. With the beetle tilted head downward, that fattened drop of water rolls down the slope of its own back, down the channels of its shell, directly down toward its waiting mouth. The beetle drinks the fog. It has turned its own body into a machine for harvesting water out of thin air. Stop and think about how extraordinary that is. This creature does not need rain. It does not need a pond or a stream or a single drop of water on the ground. It has evolved a body shape, a surface texture, and a behavior that together let it pull a drink directly out of the passing mist. It manufactures its own water from the wind. In a desert drier than almost anywhere on Earth, this beetle has solved the unsolvable problem, and it solves it fresh every single foggy morning, standing patiently on its head at the top of a dune while the gray tide rolls over it. And the trick is so effective, so elegant, that human beings have been studying this beetle intensely, trying to copy it. Engineers and scientists have looked at the precise structure of that shell, the pattern of water-attracting and water-repelling regions, and they've tried to build artificial surfaces that do the same thing, materials that could pull drinking water out of fog and humid air for people living in dry parts of the world. A beetle in the Namib Desert, going about its morning, has become a blueprint for human technology. That's how good nature's solution is. We are taking lessons from an insect on how to drink the sky. But the beetle, as spectacular as it is just one thief among many. Because it turns out that all across these fog deserts, life has independently figured out the same basic idea: harvest the fog in dozens of different forms. And if a tiny beetle can do it with its body, imagine what something much larger can do. Imagine a tree. Because the plants of these deserts are fog thieves too, and on a far grander scale. A plant can't climb a dune and stand on its head, but a plant has something the beetle doesn't. It has surface area, vast amounts of it. Think about a tree or a hardy desert shrub and all of its countless leaves, or needles, or spines. Every single one of those surfaces is a place where fog droplets can land and collect. A plant standing in the path of the incoming mist is like a giant net thrown up into the moving air, and the fog blows through it, and the droplets catch on leaf after leaf after leaf. And as they catch and merge and grow heavy, they do exactly what they did on the beetle's back. They run down. They drip off the leaves, fall to the ground, and soak into the soil right around the base of the plant, down where its own roots are waiting. The plant combs the water out of the fog with its leaves, and then waters itself with what it catches. This is the fog-catching tree, and in the desert it's a genuine lifeline, not just for itself, but for everything around it. The ground beneath such a tree can be noticeably moister than the bare desert just a few steps away, fed by the constant, gentle drip of harvested fog. And different desert plants have refined this in their own ways. Some have leaves or needles shaped to channel water down toward the trunk and the roots. Some are covered in tiny hairs, and those hairs are brilliant at snagging the microscopic fog droplets, giving them somewhere to gather. Cacti and other succulents bristle with spines, and those spines aren't only for defense, they're also fog collectors, catching droplets and directing the water down toward the body of the plant, which then stores it away like a living reservoir against the long dry stretches to come. And then there are the quietest thieves of all, the ones that don't even have proper roots. On rocks and on the ground in these deserts, you'll find lichens and certain mosses, simple, tough, ancient forms of life. They don't drink from the soil at all. They absorb water directly across their surfaces, soaking moisture straight out of the humid, foggy air like a sponge held up to the mist. When the fog rolls in, they swell and turn soft and green and spring to life. When it burns away and the dry hours return, they shrivel and go dormant, waiting sometimes for a very long time until the next gray tide brings them back. They live their entire lives in the rhythm of the fog, awake when it's here, asleep when it's gone. So now we have a whole gallery of thieves, the beetle on its head, the tree like a net in the wind, the hairy leaves and the water-catching spines, the lichens drinking straight from the air. Each one has found its own way to reach into the passing fog and steal a share of the water. But here is where the story gets even bigger, because none of these thieves exists alone. That stolen water doesn't stop with the one who caught it. It becomes the foundation of an entire chain of life, a whole web of creatures, each one stealing, in turn, from the one before. And following that chain reveals just how an entire living world can be built on nothing but fog. Once a drop of water has been pulled out of the fog, it becomes the single most valuable thing in the desert. And in nature, anything that valuable does not go unnoticed. It gets used and reused and passed along from one living thing to the next in a chain of quiet theft that runs all the way through the ecosystem. It starts with the plants, because the plants are the great water gatherers, and they turn that water into something even more useful. Using the moisture they comb from the fog, the desert plants grow. They put out leaves and seeds and tender green shoots, and in doing so, they lock that stolen water away inside their own tissues. A desert plant is, in a very real sense, a parcel of fog water wrapped in living matter, which makes it a target. Because now anything that eats the plant gets two things at once, food and water. The animals of these deserts often don't need to find a drink at all, because they get their water from what they eat. They drink in effect by chewing. The fog that the plant stole from the air is stolen again, this time by the creature that eats the plant. Insects move in to feed on the plants and on each other, and many small desert insects get most or all of the moisture they need from their food and from the humid fog air itself, never drinking liquid water in the way we'd recognize. Then come the next thieves up the chain. Reptiles, the lizards and geckos that are perfectly built for desert life, hunting those insects across the sand. When a lizard eats a fog-fed insect, the water passes up another link. There are even lizards and geckos in these deserts that can harvest fog more directly, with skin and scales structured so that droplets condense on their bodies and trickle along tiny channels toward their mouths, drinking the mist much as the beetle does. The same trick evolved all over again in a completely different animal, and it keeps going. Small mammals, like desert rodents, survive on seeds and dry plant matter, squeezing precious moisture out of food that seems impossibly dry, their bodies exquisitely tuned to waste almost no water at all. Birds pass through and hunt the insects and the lizards. Spiders and scorpions take their share. Every one of these creatures is, directly or indirectly, living off that fog. Trace any animal in this desert back down the chain, and you arrive at the same origin. A droplet of water that was hanging in the air over the cold ocean, swept inland as fog, and caught, against all odds, by something clever enough to grab it. The entire pyramid of life here, from the lichen on the rock to the bird in the sky, is balanced on top of that one act of theft, repeated endlessly, water pulled from the wind. And that is a genuinely staggering thing to realize. We are taught that ecosystems are powered by water that falls as rain and flows as rivers. But here is a whole living world, complex and layered and full of competition and survival, running on a completely different fuel, running on fog, running on a resource so faint and so fleeting that it's there for only a few hours, on only some mornings, drifting past on the wind and gone by midday. An entire community of life, timing its whole existence around the arrival of the mist. Because that's the other thing this chain depends on: timing. The fog doesn't last. It rolls in with the cool of night and the early morning, and then, as the sun climbs and the day heats up, it burns away and vanishes into the dry air. So all of this stealing has to happen in a narrow window. The beetle climbs its dune in the early hours. The lichens drink while the mist is on them. The plants catch what they can before the warmth returns. And the animals are tuned to the same clock, active in the cool, moist hours, then sheltering through the brutal heat of the day when the water is gone and the desert becomes a furnace again. The whole ecosystem pulses with the fog, springing to life when the gray tide comes in, going still and quiet when it retreats. Life here doesn't follow the seasons of rain, because there is no rain. It follows the daily rhythm of the mist. And that rhythm, that delicate dependence on a few hours of fog, is exactly what makes this world so wondrous and so fragile. Because a system this finely balanced, built on a resource this thin, is balanced on a knife's edge. Pull away the fog, even slightly, and the whole structure has nothing left to stand on. Which raises an unsettling question about just how secure these hidden worlds really are, and a hopeful one about what they might be able to teach us. To answer both, we have to step back and look at the fog deserts not just as a curiosity, but as something that might matter far more than anyone expected, both for the future of dry places here on Earth and for the question of whether life could survive somewhere far stranger than any desert on this planet. Let's start with how fragile this really is. Everything we've followed, the beetle on its dune, the fog-combing trees, the lichens, the whole chain of animals living off stolen mist, all of it rests on one thread. The fog has to keep coming. And the fog only comes because of a very particular arrangement out at sea. That band of cold water running along the coast, chilling the air and condensing the mist that drifts inland. As long as that cold current flows and that fog rolls in on its familiar schedule, the hidden world survives. But the whole thing is tuned so finely that even small changes could pull it apart. Think about what these creatures are actually surviving on. Not a lot of water, not a reliable amount. They're surviving on the bare minimum, on a few hours of mist on some mornings, harvested drop by drop with extraordinary effort. There is no reserve here, no buffer, no margin for error. A plant that catches just enough fog to live has nothing left over if the fog thins out. A beetle that drinks just enough to make it through has no cushion if the mist arrives less often. These organisms live permanently at the absolute edge of what's possible, right at the line between just barely surviving and not surviving at all. That's the price of living in a place this dry. You can make a life out of fog, but it's a life with no slack in it whatsoever. And that's why scientists watch these deserts so closely, because they are like early warning systems. If the patterns of the ocean and the air shift, if the cold currents change, or the fog starts forming differently, or rolling in less often, the creatures that depend on it have almost no room to adapt. A world that took millions of years to build itself around the mist could be unwound by a change in that mist that might seem small from the outside. These hidden ecosystems are tough, astonishingly tough, but their toughness is a kind of illusion. They are tough enough to survive the harshest dryness on Earth, and at the very same time fragile enough that a shift in a single thread, the fog, could bring the whole tapestry down. That combination, incredibly hardy and incredibly delicate at once, is the strange truth of life lived at the limit. But there is a more hopeful side to all of this, and it's where the story of the fog thieves comes full circle back to us. Because human beings have a water problem too. Vast numbers of people on this planet live in dry regions, places where fresh water is scarce and getting scarcer, where every drop matters. And we have been standing in these fog deserts, watching a beetle drink the sky and a tree comb water out of the mist, and we have realized something. They already solved a problem we are still struggling with. They figured out how to harvest water from the air with no rain, no river, and no machinery, millions of years before we ever thought to try. So we started copying them. Inspired directly by the way these desert organisms catch fog, People have built fog-catching nets, large mesh screens set up on hillsides in foggy, arid regions. The principle is exactly the same as the fog combing tree. Give the moving mist a big surface to run into, and the droplets collect on the mesh, merge, run down, and drip into channels and containers below. In the right places, these simple nets can pull a genuinely useful amount of clean water out of the fog, day after day, with no power and no fuel, gathering drinking water for communities that have very little. A trick stolen from a beetle and a desert shrub, scaled up to help people survive. The thieves of the fog have become our teachers. And then there's the largest idea of all, the one that lifts this whole story off the earth entirely. Because remember where we started. These deserts are so dry, so dead-looking, so close to the conditions on another planet, that we test our Mars rovers in them. The Atacama, in particular, is one of the best stand-ins we have for the surface of Mars. And yet, as we've seen, it is not lifeless. Life found a way to exist there, not by waiting for water that never comes, but by extracting it from the thin air, by surviving on traces, by mastering scarcity. And that is precisely the question we ask when we look at other worlds. Could anything live somewhere that hostile, that dry, that far from a comfortable supply of water? The fog deserts of Earth are quietly answering that question. They are showing us that life does not necessarily need lakes and rivers and rain. Life can dig in at the very edge of possibility, surviving on the faintest, most fleeting whisper of moisture, if it evolves the right tools to capture it. Every fog-drinking beetle and every mist-fed lichen is a small proof that the line between a living world and a dead one is not where we might assume. A place can look as barren as another planet and still hide an entire web of life, sustained by something as ghostly and as thin as fog. When we search for life beyond the Earth, in dry and brutal places that seem far too harsh to support anything, these deserts are a reminder to look closer. Because here at home, in the driest land we have, life is hanging on in conditions we would have sworn were impossible. So the next time you hear the word desert, I hope you don't just picture empty, lifeless sand. I hope you picture the gray tide of fog rolling in off a cold ocean before dawn. I hope you picture a tiny beetle climbing to the top of a dune and standing on its head to drink the sky. I hope you picture trees combing water out of the air, and lichens waking up in the mist, and a whole hidden chain of life passing a single stolen droplet from one creature to the next. Because that is the real story of these places. Not death, but survival at its most ingenious. Life refusing to give up, even where there is no rain, by reaching into the wind and stealing the water it needs to live. If this changed the way you see the driest places on Earth, tell me in the comments which of these fog thieves amazed you the most. And subscribe, because the planet is full of these impossible survivors, and there is nothing I'd rather do than keep finding them and bringing their stories to you.